Hey everyone, welcome back. I have an interesting video planned for today. I am moving a little bit into the AI space. I'm working with Storm of AI, a company which is meant for providing consultancy for AI and AI-based chatbots using GPT-4, OpenAI, LangChain, and all those interesting things. And with that experience, I have started moving a little bit into that sphere. So I wanted to get a video up and running about how to use your own custom data to interact with the chatbot. I'll explain that in a little bit more detail. So, what I mean by that is, let's ignore this page, but say I have this all right. So, actually, let me just give a demo of what I have over here. Let me get that and let me get pm node slash index.js. So the data I have over here is my admission letter. Do not mind the fact that I'm using this. I tried this with a English chapter for a CBSE, which is called The Last Lesson. It is about a kid who faces his last French lesson because the Prussians are looking to invade France, whatever. But I tried with that and it worked well. Turns out ChatGPT actually has access to it, so I couldn't figure out if that was coming from ChatGPT or from my custom data. So I used the only proper good PDF I had, which I could use for this. So this is my offer letter. I should probably hide that later, but I have this and say I wanted to ask which program I have gotten into. So I can go which program have I gotten into and say I enter that, and it will say you were admitted into the honors computer engineering co-op program, just like it is said over here. Say what are the minimum conditions that I need to fulfill. Just wait a second or two, and after that it will show that I need minimum admission average of 81%, 61% in maths, this. Diploma requirements submit by July 11. All these are this basically are summarized into this point. So this is all using my own this PDF which I used using LangChain to provide the answers to these questions. So it is very interesting how this works. It's an amazing tool. This is done within the console right now, uh, but okay, 1 second. Yeah, but in a later video we will be changing this to work in a website using Next.js. The Vercel AI SDK, which is absolutely amazing to work with, provides a very good wrapper around LangChain and OpenAI. And yeah, so let's get into how I did this. I won't write any code in this video, but it's more of an explanation on how this works. To start off with, I would like to iterate over the fact that if I was using this using LangChain in a real world application, I'll probably go with using LangChain with Python. But in this video, I know a lot of my audience is are JavaScript developers or TypeScript developers. So I went around and set up a TypeScript boilerplate over here. I just have a normal src directory. I have a .env with the OpenAI underscore API under OpenAI underscore API underscore key, so that it works with this. I'll talk about that in a second, but don't mind all the other things over here. But yeah, that's a basic starting point. To start off with, I would like to explain how LangChain works with custom data. So to start off with, what we're doing is we're taking the PDF file. In our case, that was the offer letter.pdf. We're taking that PDF and we're running it through a loader. So the loader basically loads the PDF inside the application in the required format by LangChain. Note that most of these things are LangChain things. We take the loader and we split the data into small chunks. So what that does is it allows us to create smaller chunks to have better optimization of the data and the context which is needed to bring back the answer. So if I look at this over here, let me just say splitter, LangChain, this is just the LangChain documentation. If I look at the text splitter, it has all these splitters over here. I was using the recursive character text splitter. You can go over the documentation over here. To be honest, the LangChain documentation is a little bit scattered, so it can be a little annoying to go through. But once you go through the documentation now and there, you will get a better understanding of how it works. We're basically breaking down that data into smaller chunks so that it's better to for OpenAI to find out the right chunk to get the answer from. Then the smaller chunks are run into embeddings with OpenAI. Now I'll just talk about what embeddings are in brief. I didn't plan this to write in the video, but now that I realize that it's a good point to cover. So embeddings are just vectors. Or if you have a particular text, say lorem ipsum set, or say we have apple. Now this apple has a particular vector. The vector is a numerical data, basically numerical, some I cap, 3i plus 4j, whatever, and this can have multiple parameters. So this will have so many more parameters over here. This is the unit vector. For those who don't have a maths background, even I don't, honestly. This is just the basic physics stuff that I know. But Apple might have this vector, and then say I have a fruit. All right, now fruit will have a pretty similar vector to this. All right, say this might be 4i plus 4j, and on the numerical data, vectors are easier to calculate, how similar they are. So how that is done is, it's something called cosine similarity. What OpenAI does under the hood using the embeddings is that it finds the cosine similarity with the dot product. I'm going too much into detail, but basically it just finds the similarity between two vectors. The more similar they are, the similar the word is or similar the context is. So from that, we find out how similar the context is for the answer to come in. And with that context, the new data or the response is generated. That is what embeddings are in a nutshell. Embeddings are just vector data for your text, right? Now the embeddings are generated using OpenAI, and then it is basically stored inside a vector storage. Now vector storage is just a database. It is just like PostgreSQL, MySQL, MongoDB, but they are meant for storing vectors. They are optimized for storing vectors. There are a lot of vector storages available. Where was it? Let me just find this. Yeah, so vector storage integrations. You can go through all of these. HNSWlib is just it's kind of an SQLite for vector storages. I'm using this over here. In production, you would ideally not want to use this, especially if you're hosting it on somewhere like Vercel, because Vercel does not have access to your file system. If you work with SQLite, you will know that it stores the database inside your file system, and this does something very similar. So if you're using something like Vercel, you would ideally want to use something like Pinecone, or Supabase has a vector storage called PG vector. All these things. Apparently, even MongoDB Atlas has, which I didn't know, but makes sense because it's a NoSQL database. You can use Elasticsearch and all those things. But for the purpose of this video, I've gone with something very simple called HNSWlib. Now, what we're doing is storing it inside that vector storage. Now, for the chatbot, what we're doing inside the chatbot is, this is the user. All right, let me just get this user over here. So this is the user, and the user asks an input basically. Now, when the input comes in, we pass it into a chain. What is a chain? Now, a chain is a set, a set of. I just had to restart the video, the part of the video there because of some interruption. But basically, where was that? Yeah. Yeah, so a chain. Now, so a chain is basically a set of instructions which runs one after another. Basically, it is a term inside LangChain. Oh, there it is. So it for more complex applications will require chaining LLMs. So you can have multiple LLMs. You have your OpenAI, you have something from Hugging Face. All these run in a chain step by step. Each one is called, and then it can run those sets and then give you the required logic for your application. What conversational retrieval QA chain does is, it is a chain which is inside popular over here, conversational retrieval QA. What it does is it first takes the embeddings from the vector storage and it takes the input. All right. Now it takes the input, it finds the vector for that input and finds the similarity between which context to find out. Now it takes out the context, it then rephrases that using OpenAI for a generative way of giving the answer, right? So if we talk about the description over here, it says conversational retrieval QA chain builds on the retrieval QA chain. Retrieval QA chain is to get the data back, and then you can ask a question from it. Conversational makes it conversational because it has a chat history. So for example, if I had run this over here, what program did I get accepted to? Let me think. Yeah, let me do this, and then I will have the memory of what question I had asked before. What question did I ask before? Okay, apparently I have no idea. But basically, what it does is conversational retrieval QA chain. It keeps in mind your previous questions. Oh. Okay, what we need to do over here is inside the chat history, because I'm running this inside a while throw. This is reinstantiating this data again and again. What you would ideally do for the chat history to store inside a conversational retrieval QA chain is, you will have the messages stored inside a variable, all right? Now, then you will pass in these messages over here. Now, the messages will be the system message or human message or AI message, which comes from LangChain, right? And then you will iterate over those over here, and it will have access to the previous messages over here. So ideally you would do that inside a real world application. I don't want to build this right now because I will have to spend a little more time to get that working, but it's very, very simple. Just keep a track of what all messages are being sent, and store that inside the chat history. But basically, conversational retrieval QA versus retrieval QA is that conversational has access to a chat history, right? Now, what it does is, it takes out the embedding, it finds the similarity, finds the context, gets the answer, shows the answer. That is what the chain does, and it is amazing for this particular use case. Now then, we take that and send back the response. In a nutshell, that is the explanation on how LangChain works with your own custom data. You can go over the documentation. It has this over here, I think, guides, cookbook, I think. Yeah, you can go over that. LLM chain plus retriever. It talks about this. It is using a runnable sequence, but you can find out the right conversational retrieval chain and then use that over here. I'll go over the code here in a nutshell. So basically what I'm doing is, ignore the errors. It's a new Vim thing, not configured properly. But basically I have an asynchronous function which is running on on running the file. Basically what we're doing is, first of all, running the PDF loader. Like I said, okay, this is for ingesting data. I should make that clear. Ingesting data is basically finding out the embeddings and storing it inside a vector database. That is the first step. So for that, we have an ingest.ts. We get the loader, we load the file which we are working with, all right? I have the offer letter coming inside the PDF loader, and then I call this load function. Then we run the recursive character text splitter. There are a lot of text splitters inside LangChain. You can use any of them. There's also a character text splitter. The difference is that it runs this recursively and breaks it down into smaller chunks. There is a little bit of a chunk overlap. You can set this, you can play around with these parameters however you want. There is also token text split, some token splitter. One second, token splitter. Yeah, so Yeah, token text splitter, you can use this as well. There are a lot of these. You can go over the documentation, use whatever you want. This is just what I have a lot of experiences with, so I'm covering that over here. Then we are excuse me. So we are splitting the documentation documents, calling this over here. So what this is basically doing is that these raw docs are basically, once we load this is documents of the data. Then we pass these documents inside the text splitter. You will need to go over the documentation a little bit to understand it in more detail, but this takes in a bunch of documents, basically document record. So this is a document, generic record, generic string, any list, right? Then what we're doing is we're instantiating a vector store from the documents, which is basically a split version of the raw docs. And then we're also passing the second parameter as new OpenAI embeddings. Now, this is required for the fact that you can also use something like Hugging Face embeddings for this. I've just used OpenAI because it's the standard at this point. You can use any other embeddings which you want. Also note the fact that to use this, you need to have your .env set with the um, process.env.openai underscore API underscore key. It takes in that by default, so I have used this .env package for the .env.config. And then we're storing that vector store inside a data folder, which is over here. So if I look at, say, docstore.json, it has these page contents over here, just like we would ideally want it, right? Great. And we have an args using cosine num dimensions. This is just a, you know, uh, a term which is used by HNSW for storing the similarities. So now come back to the main part of how this works with the chatbot. For that, what we're doing is, let's go a little bit down. This asynchronous function again runs itself over here. First of all, um, this prompt sync is basically just to prompt the user for a question. This is just a CLI thing. LLM, we're instantiating an LLM with Chat OpenAI. So what this is that if I look at the LLMs, Chat OpenAI. So basically, this is a wrapper around the OpenAI LLM for the chat endpoint. It uses it uses 3.5, GPT 3.5. By default, you can change that. You can use GPT 4, but it provides a chat endpoint for you using OpenAI, and you can use that as the LLM or the large language model which you want to use inside your application. Then we're taking the directory which we need to load the HNSW. So remember that we saved this over here using the vector store. Now we can load that using HNSW. Using we know the directory which it comes from, and then again pass the embeddings which it is using. Again, while true to recursively ask the question which we want to ask from the user, we get the prompt. Then we instantiate this chain which I was talking about, conversational retrieval QA chain. Dot from LLM, the first from LLM is basically we want to use this LLM and this vector store to run this chain. Now the LLM is a chat OpenAI LLM which I talked about earlier, and the vector store is we are basically running this as retriever because we want to because that is how the syntax works to work with conversational retrieval QA chain. Next, we are running this inside a try catch block, but basically we're awaiting calling the chain using the question which is being asked by the user, which is the prompt over here, and we pass in the chat history. Now, this is just a prompt engineering. You're a college admissions officer and you have access to the student's admission letter, answer doubts regarding the same. Now, you can tinker around with prompt engineering. It's a whole different topic about OpenAI and chatbots and ChatGPT and all those things. But that's a completely different topic. I don't want to get into it because I'm not a professional or have any amount of experience with prompt engineering. So you can look into that. There's an amazing course on it by Google as well now, if I remember correct. Now we pass in the system message. System message is basically the message which is prompted by the system to the AI. So that is what this is doing. You can have AI message, if I'm not wrong. Yeah, you can have AI message, say the response which is come back by the AI, and you can have a human message as well. So that was what I was doing, saying you can have messages over here, and then once this comes back, you can always append the messages with a new human message of say question and messages dot, oh, sorry, push dot push for new AI message, that, and then you can do this over here. So we know for a fact that messages, okay, this is any for now, so you can have this, what is the type of this? Looks like a system message is the type, so you can go system message or human message or AI message and have this inside. So yeah, you can do something like that, and then messages dot push. So you can go dot 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 messages. Yeah, that should work. So actually, let's try this now. So do this again. Let me copy that. Okay, that should work. Just tinker around with this a little bit. I'll look into this, and if I get a if I get how to do this, I will put this in the description or in a pinned comment. But this works. I've done this inside a production application, and this works with the with this. Okay, yeah, so that is it for this video. So basically we're just getting back this data and then console.logging data.text, which is, well, this text over here. So yeah, that is it on how LangChain works with your own custom data. And in the next video, what we will do is we will convert this into a web application using Next.js, LangChain, ShadCN UI, and the Versal AI SDK. The Versal AI SDK has amazing templates on how to use it as well. So I can go to ai.versal.com. Nope, versal.com/ai. Yeah, basically they what's the name? Yeah, so they have amazing templates on how to work with them. So if you want to go and take a look at them, please feel free to do that. I think they have a LangChain template as well. Yeah, they have this Next.js starter with LangChain, and you can take a look at that as well. So yeah, again, for the 100th time, that is it for this video. We will take a look into the Next.js version in the next video, which might take a while. Just a disclaimer, because I'm moving to Canada in a week or so, so it might take a while to get the next video up and running. So stay tuned, and keep watching. So if you like this video, please like, share, and subscribe, and keep watching. Goodbye.